Good evening, students. How are you all? Welcome to the session 3 of polynomials. So, I'm Kanika ma'am. I'm your mathematics teacher. In the last two sessions, we completed polynomials and we had started with some extra questions. So, today also we are going to revise polynomials and we'll do some extra questions. The questions which I'll be discussing in this session, they are all related to, they're all from past papers of CBSE. So, let us start with the class. Now we were discussing some questions in the previous class related to the sum of the zeros, product of the zeros, and their relationship with the coefficients. So I'll just quickly revise the same. So today also we are going to discuss the questions based on the same. So we have relationship between zeros and the coefficients of the polynomials. Now we'll talk about the quadratic polynomial for the time being. Quadratic polynomial, its standard form is given by ax square plus bx plus c. This is the standard form given to us. And it has two zeros. Let us take the zeros as alpha and beta. Now the sum of the zeros, alpha plus beta, that's the sum of the zeros, is same as minus b upon a. That is minus the coefficient of x upon the coefficient of x square. And the product of the zeros, alpha beta, is equal to c upon a. That is the constant term divided by the coefficient of x square. Now we are going to use this relationship between the zeros and the coefficients of the polynomial in the questions today. Now, so this we discussed yesterday also. Now please read this question. Find the value of k if alpha and beta be zeros of the quadratic polynomial x square minus 5x plus k, where alpha minus beta equal to 1. So the polynomial given to us is x square minus 5x plus k. If I compare this with the standard form for a quadratic polynomial, that is ax square plus bx plus c, then a is 1, b is minus 5 and c is k. Now we already know alpha minus beta is equal to 1, and also we know that alpha plus beta, that is sum of the zeros, is same as minus b by a. So we can say alpha plus beta is equal to minus 5 upon 1. B is minus 5 here and a is 1. So this gives us alpha plus beta is equal to 5. Now we know alpha plus beta equal to 5, that we've got. Also it is already given to us alpha minus beta equal to 1. Now from these two equations, we are going to solve for alpha and beta. Now let us take the second equation. From this second equation, if we take beta on the other side, we are going to get alpha equal to 1 plus beta. Now we are going to pick up this value of alpha and we are going to put it here. So we'll put this alpha equal to 1 plus beta in the first equation. So we have 1 plus beta is equal to 5. We have replaced this alpha by 1 plus beta. Now we can take this 1 on the other side and we'll get 2 beta is equal to 4. 1 we are going to take on the other side. It will get subtracted from 5. So 5 minus 1 we'll get 4. So finally we have beta is equal to 2. Now beta is 2. We can put this value of beta is equal to 2 here. And we'll get alpha equal to 1 plus beta, that is actually 2. So that is 3. So alpha we know is 3 now. So we've got alpha is 3 and beta is 2. So children, I'm repeating this question right from the beginning. We have to find the value of k, and alpha and beta are two zeros given here. Now we know the polynomial is x square minus 5x plus k. This is the polynomial given to us. Now we have compared this with the standard form for a quadratic polynomial. So a is 1, b is minus 5 and c is k. Also we know that the sum of the zeros, that's alpha plus beta in this case, is given by minus b upon a. So minus b is minus 5 and a we know is 1. So we've put the values here and we've got alpha plus beta equal to 5. And this is already given to us in the question. So I've written the same thing here. From this equation, what have I done? I've taken beta on the other side and I've written alpha in terms of beta. Now we are going to pick up this value, put it here. We'll get 1 plus beta equal to 5. So this alpha plus beta will become 1 plus beta. Alpha, in place of alpha, I've written 1 plus beta. So this, we have actually brought these two equations, we brought them down to a linear equation in one variable. So we've got here 2 beta is equal to 4. Finally, beta is 2. Now in the next step, we've picked up this value of beta and we've put it here in this equation. So alpha is 1 plus 2, that is 3. So alpha is 3. So that's how we've got the values of alpha and beta. Now we are done with this alpha and beta, but then in the question they've asked us to solve for k. So what we can do, we know that the product of the roots is given by c upon a. So like if I take the product of the roots, if I take alpha beta, that is c upon a. So that's alpha into beta is equal to c. C here is k. Just see, c here is k. So I'm going to write it as k upon 1. A we know is 1. Now alpha beta we've already got 3 and 2. So we are going to just put the values here. 3 into 2 is equal to k upon 1. So finally we'll get k is equal to 6. So finally the required value of k is 6. I hope children you've all understood this. So now let us discuss the next question. Find the value of k if alpha and beta be two zeros of the quadratic polynomial kx square plus 4x plus 4, where alpha square plus beta square is equal to 24. So this is the polynomial given to us, and we know that alpha and betas are zeros of the polynomial. So I'm going to compare this with the standard form for a quadratic polynomial. So from here we can see a is k, b is 4, c is k. Also we know alpha and beta are zeros of the given polynomial. So alpha plus beta is given by minus b upon a. So that is minus 4 upon k. And the product of the zeros, alpha beta, is given by c upon a. That is k upon k. That is actually 1. So we can say alpha beta is equal to 1. Oh, okay. Wait a minute. Copied this wrong. This one is 4. Okay. So I'm just repeating this. This is 4. Please notice this is 4. I've copied incorrectly here. So this is c is also 4 in this case, and then we've got alpha into beta. Alpha into beta is c upon a. That is actually 4 upon k in this case. That's all. We'll not write it as 1. Okay. Now the next step is, we already know alpha square plus beta square is equal to 24. This we already know. Okay. So now if I take this alpha plus beta whole square, this can be written as alpha square plus beta square plus 2 alpha beta. We know alpha plus beta equal to minus 4 upon k. So we are going to put this value here. We'll get minus 4 upon k whole square. And we also know alpha square plus beta square is 24. So I'm going to replace this by 24 and 2 times of alpha beta. That is the product of roots. Alpha beta, we know it's 4 upon k. So we'll write it as 2 times of 4 upon k. In the next step, we are going to simplify this. We will get 16 k square, 16 upon k square equal to 24 plus 8 upon k. 2 into 4 I've written as 8. Now we are going to take the LCM here. We'll get 16k square is equal to 24k plus 8 upon k. Now this is k square and this is k. We are going to cancel one of the k's here and we'll be left with 1k here. Now this 1k we can take on the other side and it will get multiplied. So we will get here 16 is equal to k times of 24k plus 8. So I have taken this k on the other side and I have multiplied this with the numerator here. In the next step, we'll get 16 is equal to 24k square plus 8k. So we have multiplied this k inside. Now as we can see, 16, 24 and 8, they're all divisible by 8. So I'm going to divide both LHS and RHS by 8. So from here I'll get 2 is equal to 3k square plus k. Now 2 I'm going to take on the other side and I will get 3k square plus k minus 2 is equal to 0. So here we are going to solve for k using split the middle term. We want two numbers whose product is minus 2 into 3, that is actually minus 6, and the sum is 1. So if I take 3 and negative 2, I'm going to get the product as minus 6 and I will get the sum as 1. So I'll write this k as 3k minus 2k. So we have here 3k square plus 3k minus 2k minus 2 is equal to 0. So we have split this term. Now in the next step, we'll take 3k common from here. We'll get k plus 1. And from these two terms, we are going to take minus 2 common. We'll get k plus 1. Now as we can see, k plus 1 is common. We'll take that common and we'll be left with 3k minus 2. From here, we can say either k plus 1 is equal to 0 or 3k minus 2 is equal to 0. So we can say either k is equal to minus 1 or k is equal to 2 upon 3. So these are the required values of k. Children, I hope you've understood this. Now let's discuss the next question. So there are a few parts for this question. This quadratic polynomial is given to us and we know alpha and betas are zeros of the quadratic polynomial. If alpha and beta be zeros of the quadratic polynomial 3x square plus 5x plus 13, then evaluate 1 upon alpha plus 1 upon beta. Now we have this as the quadratic polynomial. So before we start with anything else, we are going to compare this with the standard form for the quadratic polynomial ax square plus bx plus c. So from here we get a as 3, b 5 and c 13. Now we have to solve for 1 upon alpha plus 1 upon beta. So alpha and beta are given to be zeros of the polynomial. So we have alpha plus beta is equal to minus b upon a, that is minus 5 by 3. And alpha beta as c upon a, that is 13 upon 3. Now I'm going to write this 1 upon alpha plus 1 upon beta. I will take the LCM in the next step. I'll get alpha plus beta over alpha beta. Now alpha plus beta is minus 5 upon 3 and alpha into beta is 13 upon 3. We can cancel out these 3's and we'll get minus 5 upon 13. Finally, the value of 1 upon alpha plus 1 upon beta is given by minus 5 upon 13. I hope children you've all understood this. Now let's proceed. We have to solve for alpha square plus beta square. So this is the same part for this question. We'll be considering this as this polynomial and we'll solve for alpha square plus beta square. Here I'm going to take alpha plus beta whole square. So this is of the form a plus b whole square. That can be written as a square plus b square plus 2ab. Now alpha plus beta. Let us solve for alpha plus beta. This is already done. Minus 5 upon 3. So I'm going to replace this by minus 5 upon 3 whole square. I don't know this value. I'll just write it as it is. This is what we need to solve for. 2 times of alpha beta. So alpha beta here is 13 upon 3. It is 13 upon 3. Now we'll simplify in the next step. We will get 25 upon 9. Alpha square plus beta square. This we'll get here 26 upon 3. And in the next step, we'll take this on the other side. So we will get 25 upon 9 minus 26 upon 3 equal to alpha square plus beta square. In the next step, we are going to take the LCM. So we will take the LCM as 9 here. So we'll get 25 minus 78 over 9. In order to make this 9, we'll multiply this by 3. This also we'll multiply by 3. So this is alpha square plus beta square. Now in the next step, we have to find the difference of 78 and 25. Let us see how much is that. So we'll get here 3 and then 53. So it's minus 53. Actually, we have 25 minus 78. So it's minus 53 over 9. That is alpha square plus beta square. Finally, we have got this alpha square plus beta square as minus 53 upon 9. Okay, I hope you've understood this. Let us proceed. In this part, we have to solve for 1 upon alpha upon beta plus beta upon alpha. So we'll first simplify this. We are going to take the LCM. We will get alpha beta here. And here we are going to get alpha square plus beta square. So this one is very simple. Alpha square plus beta square we've already solved for in this step. So we'll not do it again. We'll just pick up this value and we'll put it here. So we will get minus 53 upon 9 upon alpha beta. Upon alpha beta, that means I have to write this value, 13 upon 3. 13 upon 3. Now we will solve this. We'll get minus 53 upon 9. We'll times it by 3 upon 13. Actually, we have multiplied by reciprocal of the denominator here. So here, this is 1 and this will give you 3. And finally, you will get minus 53 upon 3 into 13, that is 39. That is the final answer. So the value of this is minus 53 upon 39. So like this, you can get in the exam, you can get one polynomial and you can get in different forms like 1 upon alpha, 1 upon beta. So everywhere, if you take the LCM and you simplify them, you will actually be using the relationship between the coefficients and the sum and the product of the zeros. So somehow try to make it in the form of in the sum and the product of zeros, because the same you are going to derive from the polynomial only. So all the questions which we are doing today, they're all based on these alpha, beta, all of them based on sum of the zeros and product of the zeros. Now in the next question we have, if the sum of the squares of the zeros of the polynomial 6x square plus x plus k is 25 upon 36, find the value of k. So we'll first write down the polynomial. This is the polynomial given to us. We'll compare it with the standard form. So we have a as 6, b 1, c k. Let us take the zeros as alpha and beta. It is given to us sum of the squares of zeros. We will take the squares of zeros and then we are going to add them. Sum of the squares of the zeros is alpha square plus beta square. It is not alpha plus beta whole square. Please try to understand. You square the zeros and then you have to add them. If the sum of the zeros of the polynomial is 25 upon 36, so it's given to us. If this is 25 upon 36. Now this is what you know. You have to solve for the value of k. So before you do that, you can just write down the sum of the zeros. Alpha plus beta, that is minus b upon a. That is minus 1 upon 6. And alpha beta, that is c upon a. That is 6 upon k. Now we know these three things. We know alpha square plus beta square. We know alpha plus beta, and we know alpha into beta. Then let us take alpha plus beta whole square. This is alpha square plus beta square plus 2 alpha beta. Now alpha plus beta, we know it is minus 1 by 6. And alpha square plus beta square, I'm writing as it is. In fact, we can write, we can write this. It's 25 upon 36, it's given to us. Okay, now I'm going to write here 25 upon 36. And then we have 2 times of alpha into beta, that is actually 6 upon k. Here we have to find the value of k. So I'm going to write this as 1 upon 36. This I'll write as 25 upon 36. And this is 2 times of alpha beta, that is 2 times of 6 upon k, that's actually 12 upon k. Now I'm going to take this on the other side. I will get 1 upon 36 minus 25 upon 36 is equal to 12 upon k. Since we have the same denominators, we will not take the LCM. We will just directly work on the numerators. So we have 1 minus 25 over 36 and then we have 12 upon k. Now this will give us minus 24 upon 36 is equal to 12 upon k. And then we can cancel out. So we can cancel 24 and 36 by 12. We'll get 2 times here, we'll get 3 times here. So we have minus 2 upon 3 is equal to 12 upon k. Now we have to solve for k. We'll take the reciprocals. So we'll get minus 3 by 2 here and we'll get k upon 12. 12 I'm going to take on the other side and it will get multiplied. So we'll get minus 3 upon 2 into 12 is equal to k. And we can cancel out this. We'll get here 6. And finally, we have minus 18 is equal to k. So we have the value of k as minus 18. Have you all understood, children? Okay. Now let us discuss the next one. If one zero of 2x square minus 3x plus k is reciprocal of the other. So we have two zeros here. Let's take the 0 as alpha and the other one is reciprocal of the other. I'll take 1 upon alpha. And this is the polynomial given to us. We have 2x square minus 3x plus k. Now, if one zero of this is reciprocal of the other, we have to find the value of k. We've got the zeros as alpha and 1 upon alpha. We've written the polynomial also. Now, here as we can see, a is 2, b is minus 3 and c is k. And we know that the sum of the zeros is minus b by a, and let us take the product of the zeros. We will be using the product of the zeros here. Alpha into 1 upon alpha is c upon a. We can cancel out this and we will get here 1 is equal to c upon a. Finally, we have a is equal to c. I've taken this a on the other side and I've multiplied this. So it's a is equal to c. A is c, that means 2 is equal to k. We have now got the value of k as 2. That's all. Now let's find the zeros of the polynomial root 3x square minus 8x plus 4 root 3. So we are going to do it by split the middle term. Here we want two numbers such that the product is 4 root 3 into root 3. 4 root 3, that's the constant term, multiplied by the coefficient of x square. So you will get actually here 4 into 3, that is 12. So we want the product as positive 12 and the sum as negative 8. So if we take minus 6 and minus 2, we are going to get the product as positive 2 and we'll get the sum as minus 8. So from here we will get minus root 3x square minus 6x minus 2x plus 4 root 3. Now we can take common, but then before we do that, I'm going to write this 6 as 2 into 3, and if I'm writing this 6 as 2 into 3, this 3 can be written as 2 into root 3 into root 3. So I'll write it as 2 into root 3 into root 3 x, and this I'm writing as it is, minus 2x plus 4 root 3. Now please notice here, we have root 3 common and we have one of the x common. Here we have x square, we have 2x here, but then we have only 1 here. So we'll take root 3x here, and then we have x minus 2 root 3. X is left from here, minus we have, then we have 2, and then we have one of the root 3s here. And in these two terms, I'm going to take minus 2 common. So I have x minus 2 root 3. So please notice this bracket is the same. So we'll take this common. We'll get x minus 2 root 3 here. And then we can take this root 3 x minus 2. So finally, the zeros of this polynomial, we have x as 2 root 3. So this is going to become 0 only when both of them are 0 or one of the brackets is 0. So we have x as 2 root 3 or we have x as 2 upon root 3. You can also rationalize this. If you multiply this by root 3 upon root 3, you are going to get x as 2 root 3 over 3. So these are the required values of x. Children, I hope this is clear to you. Now let's proceed. If one zero of the polynomial a square plus 9x square plus 13x plus 6a is reciprocal of the other, then find the value of a. So we have a square plus 9x square plus 13x plus 6a. From here we can say that if I compare this with ax square plus bx plus c, I will get a as a square plus 9, b as 13, and c is 6. Now, 1 0 of the polynomial is reciprocal of the other. So, if I take 1 0 as alpha, the other one would be 1 upon alpha. These are the two zeros which we have. Now, we have to solve for the value of a. So, let us take here the product of the zeros. So, we have product of the zeros as alpha into 1 upon alpha, that is c upon a. We can cancel out this alpha. We will get 1 is equal to c upon a. And then we have a is equal to c. We have a is equal to c here. We are going to put the values of a and c here. We will get a square plus 9 equal to 6a. A square plus 9 is equal to 6a. Now, in the next step, we will take this 6a on the other side and this will become minus 6a. So, we have a square minus 6a plus 9 is equal to 0. Now, we'll solve this using spread the middle term. We have to solve for the value of a. So, I'll just write it here again. A square minus 6a plus 9 is equal to 0. We want two numbers whose product is 9 and sum is minus 6. So, we can write this as a square minus 3a plus 9 is equal to 0. Now, minus 3 I have written because I want the product to be positive 9 and I want the sum to be minus 6. In the next step, we'll take a common here and we have a minus 3. And here we will take minus 3 common. So, we have a minus 3 again. And we can see here we have a minus 3 common. We'll take this outside and we will be again left with a minus 3. So, here a is 3, 3. In both the cases, we're getting 3. So, finally, the required value of a is 3. So, find the value of a. A was asked in the question. So, we have solved for a as 3. Okay. Now, let us discuss the next question. Find the condition that the zeros of the polynomial ax square plus bx plus c are reciprocal of each other. So, we have to find a condition here. We don't have to solve for any values here. It's given to us that there are two zeros of the polynomial and one is reciprocal of the other. So, if one is alpha, the other one is 1 upon alpha. Now, let us take the product of the zeros. Now, we know that the product of the zeros is given by c upon a. We can cancel out this alpha and we have 1 is equal to c upon a. Finally, we have a is equal to c. We have a is equal to c. So, if a is equal to c, then this is the condition for 1, 0 to be reciprocal of the other. Now, coming to the next question. If alpha and beta are zeros of the polynomial x square minus x minus k such that alpha minus beta equal to 9, we have to find k. So, this is the polynomial given to us and we'll compare this with ax square plus bx plus c. So, a is 1, b is minus 1 and c is minus k. Now, alpha and beta are given to be zeros of the polynomial. So, we know alpha plus beta is equal to minus b upon a. That is actually minus 1 upon 1. So, that's actually positive 1. So, we have alpha plus beta is equal to 1 here. Now, the product of the zeros is given by c upon a, that is minus k upon 1. So, alpha beta we know it is minus k. Now, these two, now we have got the sum of the zeros. We've also got the product of the zeros. And this is given to us already. We already know alpha minus beta is equal to 9. This we know. And now, it's very simple. This we already know. And then we know alpha plus beta equal to 1. So, just put it here. And we have to first solve for alpha and beta. We're going to first solve for alpha and beta. So, what I'm going to do here. We can take this beta on the other side and from here we will get alpha equal to 9 plus beta. I'm going to put this value here in this equation. So, I'll get 9 plus beta plus beta is equal to 1. So in place of alpha, I've written 9 plus beta. So 9 plus beta equal to 1. In the next step, we are going to solve this. We can combine the like terms and we'll get 9 plus 2 beta is equal to 1. So 9 we'll take on the other side. We'll get 2 beta is equal to 1 minus 9. 2 beta is equal to minus 8. And finally, beta is minus 4. So beta, we have got minus 4 here. And we have to now solve for alpha. So I'm going to put here beta is minus 4. So alpha is equal to 9 plus beta, we know. So alpha is equal to 9 plus minus 4. Finally, we have alpha as 5. So alpha here is 5. So alpha is 5 and beta is minus 4. Now we've got the values of alpha and beta. We will now solve for k. So if we get the values of, we've already got the values of alpha and beta. I'm going to put the values here. So we have here alpha beta is equal to minus k upon 1. So we can just write it as minus k. Alpha is 5, beta is minus 4 is equal to minus k. Then we get minus 20 is equal to minus k. Finally, we have k as 20. So the required value of k is 20. I hope you've all understood this. Okay. Now the next one. If p and q are zeros of the polynomial px, 2x square minus 7x plus 3, find the value of p square plus q square. So this is the polynomial given to us. And if we compare this with the standard form, we will get a as 2, b as minus 7 and c 3. Now we know that p and q are zeros of the polynomial. So p plus q, that is sum of the zeros, is minus b upon a. So in this case, we have 7 upon 2. I've written 7 by 2 because it's minus 7 by 2, that is positive 7 by 2. And then pq is 3 upon 2, that is c upon a. Now we have to find the value of p square plus q square. So if I take p plus q whole square, that is p square plus q square plus 2pq. Now p plus q is 7 upon 2. I'll replace this by 7 by 2. So I will get here 7 by 2 square equal to p square plus q square plus 2 times of pq. So pq is actually 3 by 2. Now we'll get here 49 upon 4. And then this is p square plus q square. And I can cancel out these 2's and I'll get here 3. Now I'm going to take this 3 on the other side. We'll get 49 upon 4 minus 3 is equal to p square plus q square. We can take the LCM here. We'll get 4 as the LCM. And then we have 49 minus 12 here. So 49 minus 12 would be 37. So we have 37 upon 4. That is p square plus q square. Finally, the value of p square plus q square is 37 upon 4. This is the required answer. Children, I hope you've understood this. Now let's discuss the next question. If the zeros of the polynomial x square plus px plus q are double in value to the zeros of 2x square minus 5x minus 3, find the value of p and q. Children, I'm repeating this question. If the zeros of this polynomial are double in value to the zeros of this. So for this one, if I take alpha, beta as the zeros, so for this one, the zeros would be 2 alpha, 2 beta because they're given to be double of this one. Now we have 2x square minus 5x minus 3. I'm writing this polynomial. I know that alpha and beta are zeros of this polynomial. I've taken them as alpha and beta. So the sum of the zeros here is minus b upon a, that is minus 5 upon 2, that's 5 by 2. And the product of the zeros is c upon a, that is minus 3 by 2. So let's keep these equations aside, we'll be using this. Now coming to this one, we have x square plus px plus q. So if alpha betas are zeros of this polynomial and the zeros of this polynomial are double in value of this one, so this would be 2 alpha and 2 beta. So I'm going to take the zeros as 2 alpha plus 2 beta. Here the sum of the zeros is minus p. It's minus p upon 1 actually. That's minus b by a. I'm just writing it. It has minus p. And the product of the zeros here is c upon a. That's q upon 1. That's q1. Now we have to find the values of p and q. So from here, let's take the third equation. This has third equation and this has the fourth one. In this third equation, we can take 2 common. If I take 2 common, I'll have alpha plus beta here. That is minus p. And then I'm going to take this alpha plus beta. Alpha plus beta is 5 by 2 here. So we have 2 times of 5 by 2. That is minus p. This will get cancelled and we have p as minus 5. I've taken this minus on the other side. Now I've got the value of p. I'll now solve for q. So I'll take this fourth equation as 2 alpha into 2 beta. I'm writing this as 4 alpha beta is equal to q. It's 4 alpha beta equal to q. Now alpha beta I know is minus 3 by 2. So I'll replace this by minus 3 by 2. And then we can cancel out 4 and 2. This will get cancelled. And then we have 2 into minus 3. That's actually minus 6 is equal to q. We've got minus 6 is equal to q. So we can say that q is equal to minus 6. Finally, we have p as minus 5 and q as minus 6. So in the question, they were asking us to solve for the values of p and q. We've got the same. So this is the required answer. Now let's proceed further. This one is very easy. We did this yesterday also. Form a quadratic polynomial px with 3 and minus 2 by 5 as sum and the product of its zeros respectively. So the quadratic polynomial, the formula for forming a quadratic polynomial is x square minus sum of zeros into x plus the product of zeros. Now in this question, the sum and the product, they're both given to us. That's x square minus 3x plus the product of zeros, that is plus of minus 2 by 5. So we can write this as x square minus 3x minus 2 by 5. This is the required polynomial. You can also take the LCM and you can write this as 5x square minus 15x minus 2. You can write like this also. They both represent the same thing. Now, in this question, it's given to us if the sum of the zeros of the polynomial a plus 1x square plus 2a plus 3x plus 3a plus 4 is minus 1, then find the product of its zeros. So, this is the polynomial given to us. This is ax square plus bx plus c. So, from here we can see that a is actually a plus 1, b is 2a plus 3 and c is 3a plus 4. Let us take the zeros as alpha and beta, and it's given to us if sum of the zeros of the polynomial is minus 1. So alpha plus beta is minus 1. The sum of the zeros is given to be minus 1. We have to find the product of the zeros. So before we do anything else, I'm going to put this alpha plus beta. I also know it is equal to minus b upon a. So minus b by a, that means it is minus b by a equal to minus 1. I will take this a on the other side and I'm going to actually get minus b is equal to minus a. A will get cancelled and then I will have a is equal to b. So this is a and this is b. So I will write a plus 1 here and then 2a plus 3 here. Now I'll solve for a. 3 I'll take on the other side and a I'm going to take on the other side. So I'll get 1 minus 3 and I will get here 2a minus a. So this is minus 2 is equal to a. Finally, we've got the value of a as minus 2. We have a is equal to minus 2. Okay, now I've got a as minus 2 and I also know that the product of the zeros is actually I have to solve for the product of the zeros. So the product of the zeros I know it is c upon a. So if I write the product of the zeros as c upon a, that is actually product. Let's take here alpha beta is equal to c upon a. That is 3a plus 4 upon a plus 1. And I know the value of a also now. I'll just put the value here. So this is what we get here, minus 2 plus 1. So this is minus 6 plus 4, that's minus 2. And this is minus 2 plus 1, that is minus 1. So finally, the product of the zeros here, alpha, beta is equal to positive 2. So the answer here is positive 2, that is the product of zeros. I hope children you've all understood this. Now let's discuss the next question. It is a bit different from this one. Find a quadratic polynomial whose zeros are 3 plus root 2 and 3 minus root 2. So the zeros are given to us and we know the formula for forming a quadratic polynomial, that is x square minus sum of the zeros into x plus the product of the zeros. We know this. So the zeros are given to us. We first solve for the sum of the zeros. That is 3 plus root 2 plus 3 minus root 2. You can cancel out this and you will get here 6. And then let's solve for the product of the zeros. 3 plus root 2 into 3 minus root 2. So this is of the form a plus b into a minus b, that is a square minus b square. So this is actually 9 minus 2, that is 7. This is sum of the zeros and this is product of the zeros. And we know the formula for solving this is x square minus sum of the zeros into x plus the product of the zeros. That is x square minus 6x plus 7. So this is the required quadratic polynomial. Now let's discuss one more question. If alpha and beta are zeros of the polynomial 3x square minus 6x minus 7, then form a quadratic polynomial whose zeros are 1 upon alpha and 1 upon beta. So alpha and beta are given to be zeros of this polynomial. We have to form a quadratic polynomial so that we get the zeros as 1 upon alpha and 1 upon beta. So actually there is no need to find alpha and beta and no need to find 1 upon alpha and 1 upon beta. If I know the sum of these zeros and if I know the product of the zeros, then I'll be able to form a quadratic polynomial. So I'm going to write this polynomial here. Then I know here a is 3, b is minus 4 and c is minus 7. Sum of the zeros, I'm actually talking about alpha and beta here. Alpha plus beta, that is minus b by a. So that is 4 by 3. And the product of the zeros here is minus 7 by 3. That is actually c by a. Now I need to form a quadratic polynomial whose zeros are 1 upon alpha and 1 upon beta. I'm going to solve for the sum of the zeros here. That is alpha plus beta upon alpha beta. So alpha plus beta is actually 4 by 3. And then alpha beta is minus 7 by 3. So I will get 1 upon alpha plus 1 upon beta. That is sum of the zeros as 3. I can cancel. I get minus 4 by 7. I've got the sum of zeros. Now I'll solve for the product of the zeros. So we have 1 upon alpha into 1 upon beta. That is 1 upon alpha beta. And I know this is alpha beta. So I'll write 1 upon minus 7 by 3. So actually I'll get minus 3 by 7. I'll take the reciprocal. I'll get minus 3 by 7. This one is 7. That's how I've got the product of roots. Now I have the product of roots. I have the sum of the roots. I can find this, find the required polynomial. So I will get here x square minus 4 by 7x minus 3 by 7 is equal to 0. So it is x square minus sum of the zeros. So this would be plus actually because the sum of the zeros is minus 4 by 7. So it's minus 4 by 7. So x square plus 4 by 7x plus the product of the zeros. It's plus the product of zeros, so it's actually minus 3 by 7. So you can either write like this or you can take the LCM and you can write this as 7x square plus 4x minus 3. This also you can write. This is the required polynomial. Either this one or this one. Okay, so we'll not write it equal to 0 because it's given to be a quadratic polynomial. It's not given to be equation. It's not given to be quadratic equation. It's polynomial. So we just write like this. Okay, so children, enough of practice today, and we have actually completed polynomials. So we'll just quickly revise this. I'll just summarize this topic first. So polynomials we discussed. Polynomials is a type of algebraic expressions only, but in polynomials we can have the powers of the variables only as whole numbers, whereas in algebraic expressions we can have the powers of the whole powers of the variables as any rational number. Now the polynomials, their degree is defined as the highest power. So if you have the polynomial like you have here x square plus 2x plus 3, the highest power here is of x square. So the degree of this polynomial is 2. It's the highest power. Polynomials we classify on the basis of number of terms and on the basis of the degree of the polynomial. So if a polynomial has just one term, we call it a monomial. If a polynomial has two terms, we call it a binomial. If a polynomial has three terms, we call it a trinomial. A polynomial with degree 0 is called a constant polynomial. Like we have numbers here 25, 9, root 5. They're all constant polynomials. And 0 polynomial, however, it is a constant polynomial, but still we have given a special name to it, that is 0 polynomial. A polynomial with degree 1 is called a linear polynomial. A polynomial with degree 2 is called a quadratic polynomial. And if we have degree 3 for a polynomial, we call it a cubic polynomial. Now, zeros of the polynomial are those numbers which make the value of the polynomial 0. Geometrical meaning of zeros of the polynomials. So, geometrically, the zeros of the polynomial are the points where its graph cuts the x-axis. So, wherever the graph is cutting the x-axis, that is 0 of the polynomial. Like in this case, the graph is cutting at x is equal to minus 2. So, this is the 0 of the polynomial. Now, in this graph, this line is cutting the x-axis. The graph is cutting the x-axis at one point, so it has 1 0. It is cutting this x-axis at 2 points, it has 2 zeros. This is cutting the x-axis at 3 points, it has 3 zeros. So in general, we can say that a polynomial of degree n has at most n 0. So if it's a linear polynomial, it has degree 1, it has 1 0. If it's a quadratic polynomial, it has degree 2, it has 2 zeros. And for a cubic polynomial, at most we have 3 zeros. Now something very important which we had discussed today in detail, the relationship between the zeros and the coefficients of the polynomial. So for the linear polynomial, we have standard form as ax plus b. So the polynomial reduces to 0. The value of x for which the polynomial reduces to 0 is minus b by a. So x here is minus b by a. And if we have a quadratic polynomial ax square plus bx plus c, and we have two zeros for the quadratic polynomial, that is alpha plus beta, that is minus b by a, and alpha beta, that is c by a. And if we know that there are two zeros of the quadratic polynomial, and we know that this their sum and product, then we can form the quadratic polynomial using this formula, x square minus sum of the zeros into x plus p, that's the product of the zeros. All right, children, so I'm winding up here. So we've completed with polynomials chapter. In the next class, we are going to start with linear equations, pair of linear equations and two variables. That's the third chapter.